Hi, in this video, we're going to have a look at a third, more complicated example. It doesn't look that bad, I suppose, but it's complicated enough to give us a bit of an idea of where we can go with this kind of stuff, because this particular integral here has a function, an inside function and an outside function. So we're going to use substitution to solve it. Now, I'm going to show you two ways of doing it. One way is, I guess, less thought but more mechanics, and the other way is a bit more thoughtful and therefore is a bit more efficient in the end, I think, anyway. So I'll go with the longer way first, um, just so you can get a sense of what's going on, and then we can move on from there. So we've got an integral from -1 to 1 of 2x minus 3 to the power of 3 dx, and I'm going to use my usual substitution methods to progress this one. So I'm going to start off with um, let u equal the inside function, 2x minus 3. So therefore, du is equal to, well, the derivative of 2x minus 3 is just 2. And that's with respect to x. So du equals 2 dx. And then because I'm interested in dx, not 2 dx, I'm going to multiply both sides by a half. So I get a half du is equal to dx. So that's fine. This is just like what we've been doing normally. And the effect that it has is as follows. Now, I've deliberately not put the boundaries on the integral sign to start with, but I will have my 2x minus 3 ends up being a u. So I've got u cubed. My dx becomes half du. So there's my du, and I put my half here. Now, this is the critical thing. We have now got an integral with respect to a different variable, but the boundary conditions that we were given are boundaries for x, not for u. So I'm just going to spell it out here that it's from x equals -1 to x equals 1. Okay, so that's really important that we remember that this is based upon x values, not u values. Now I'm going to find the integral of a half u cubed. That's not too bad. So that's equal to, and again, I'll use my notation of the square brackets. So u cubed goes to u to the power of 4, and so a quarter goes back here, and I had a half to start with. So I've got a half times a quarter u to the power of 4, and that's from x equals -1 to x equals 1. Again, just putting the x equals in there to remind ourselves that we need to convert back before we do anything. Okie dokie. So let's simplify this a little bit. I'm going to do a couple of steps here just to make it a bit simpler. A half times a quarter is an eighth. And because this is just a constant value, an eighth, I can take the eighth outside the brackets. So I'm going to say that's equal to an eighth of u to the power of 4 between x equals -1 and x equals 1. And then I'm going to just go to slide 15 now, and I'm going to say, I'm going to evaluate that now. And so that's going to be 1/8 multiplied by 5 to the power of 4. Okay. Oops, sorry, jumping the gun there. That's 1/8 of 2x minus 3 to the power of 4 between, now I don't need the x equals now, so I can just go between -1 and 1 because we're now all in agreement. Now we can do the substitution in and solve. So that's 1/8 multiplied by, here we go, 2 multiplied by 1 minus 3 to the power of 4 minus 2 multiplied by -1 minus 3 to the power of 4, like so. So that's going to give me 1/8 of, I'll try and do a couple of these steps in now in my head so that we're good to go. 1/8 of, well, 2 times 1 is 2, 2 minus 3 is -1, -1 to the power of 4 is 1. This one here is 2 times, oops, 2 times -1 is -2, -2 times, -2 minus 3 is -5, -5 to the power of 4 is 625. So I've got 1 minus 625. Oops, wrong bracket there. Not that it really matters. Okay, and then we can go from here. So 1 minus 625 is negative 624. So we've got negative 624 over 8. Okay, just it's going to be 1 times 624 to get me 624. 8 times 1. Okay, so I hope that's okay. If your fraction knowledge is a bit weak, that might be a bit of a step too far, but if that's the case, then we'll have to do something about it. And then lastly, everyone knows that 624 divided by 8 is equal to 78, and so it's negative 78. Now, again, I'd say that with tongue-in-cheek. 8 goes into 62. I'm just doing shorthand division in my head. You could do it on a piece of paper if you needed to. 8 goes into 62 7 times. 8 sevens are 56. So there's my 7 with 6 left over. So that's 64. 8 goes into 64 8 times exactly. So we get 78. And because it's negative 78. Okay, and that's it. That's solved. So the steps are we use a substitution method as usual. We simplify. We then substitute back, and then we are good to go by substituting those numbers in. Now, here's, I think, a more efficient method, but it does require you to think a little bit. So pay careful attention to this. We start off the same way. The integral from negative 1 to 1 of 2x minus 3 to the power of 3 dx. And we start off the same way by saying let u equal the inside function, which is 2x minus 3. And then we say du is equal to 2 dx. So a half du equals dx. So this is just like we did in the other problem. But here's the little change we're going to make. What we're going to do it in your head, but I'll write it down on this piece of paper so that you can sort of see the thinking, is we're going to reclassify the boundary numbers by considering what the u value would be. So now we're just going to do a little bit of thinking. And we say, the lower bound is negative 1. So if if x equals negative 1, u is equal to negative 5. And if the upper boundary is 1, then when x equals 1, u is equal to negative 1. And so our integral, I might actually just do it a bit further up the page, just so that I can try and fit it onto this one slide. So our integral now becomes the integral from negative 5 to negative 1. Okay, so I've got new lower and upper bound of a half u to the power of 3 with respect to u. Okay, so I've recalculated the boundaries, and the reason why is because I can now find the integral of with respect to u, and that would be, again, u to the power of 4. Put the quarter down here. I had a half to start with from minus 1 down to minus 5, okay? So notice there are no x's involved at all, and nor do I ever go back to the x's. So from here, I'm just going to shortcut a little bit. 1/8 of u to the power of 4 between minus 5 and minus 1. And now I'm going to do my substitution in, and I'm going to have 1/8 minus 1 to the power of 4 minus negative 5 to the power of 4. Okay, that gets me 1/8 of 1 minus 625. And just to fit it onto this slide here, that'll give me negative 624 on 8, and that is equal to negative 78. The same as I had over in slide 15 from this point on. So from here, sorry, it's basically the same as here. But I didn't have to go back and figure out all the xy things here because I'd effectively done it earlier on. So I think it's a little bit more efficient doing it this way, because by redefining the boundaries in terms of U, I never have to go back to X. And I think that probably assists us in getting a solution. Substituting -1, -5 in for U to the power of 4 here is just a little less complex than doing it at this point here, I think. Anyway, either way is fine. You'll find the textbook does it this way, but I think this way is a little bit more effective. What do you think? You choose whichever method that you want to do it as, and just practice that method so that it's nice and tight. Okay, we'll leave it there.